All right. Today we're going to look at well, I guess not today, but now we're going to look at a zero launch problem. Okay, zero launch refers to a problem where there is a projectile launched horizontally. Okay? So, in this problem, it's actually a yes or no problem. We want to know if a pumpkin kicked off the roof of GDS at 12 meters per second in the horizontal direction, again, zero launch, will clear CA's car, which is 18 meters away and 1.5 meters tall. So we've got an M. So, how do we find that? Well, in any kind of two-dimensional problem, we want to break it up into X and Y. So, first thing we're going to do is we're going to write down what we know in X and what we know in Y. Alright, so in X, we've got change in X. Well, let's wait on change in X. We know some X directions, but none of those are some X distances. We don't know any of the X distance that actually refers to how far the pumpkin goes. So we just know the X distances of CA's car, which is not the same thing. Okay? We've got V initial, which is going to be 12 meters per second. Okay? We've got, well, V final, which we don't know. We've got acceleration, which is going to be 0. Again, in the X direction, we got no acceleration. And we've got time, which again, we don't know yet. Okay? In the Y direction, we have change in Y. Again, we know some Y. Okay, we know that how far the pumpkin goes to the ground is 15 meters. And we know the height of CA's car, but again, we haven't quite figured out what our end game is. So let's hold off on that for a second. Okay, we know V initial, well, 0. V final, we don't know. Acceleration is negative 9.8. And time, we don't know. So now let's, oops, not 0, we don't know it. So now let's consider what options we have. How can we show whether this pumpkin is going to hit CA's car or not? First thing we need to know is that there's two ways to solve this problem, and we have our choice. Okay? The first way is that we can sit there and be like, okay, CA's car is 18 meters away. If the pumpkin is above 1.5 meters at that point, it'll pass over CA's car. If it's below 1.5 meters, it's going to hit CA's car. Makes sense, right? The other way to solve it is like, okay, let's figure out when the pumpkin is 1.5 meters off the ground. Alright, if it's 1.5 meters off the ground here, clearly it's going to hit CA's car. If it reaches 1.5 meters off the ground over here, it's clearly past CA's car. Okay? And we're going to do it that second way. So change in Y is going to be 15 minus 1.5, or 13.5 meters. Now, as always, we got our rule of 3. If we have 3 of these, we can find something else. Alright? Now, what do we want to find? Well, in a two-dimensional problem, the only thing that crossovers we have is time. So almost always we want to find time. So let's figure out how we can find time from this information. Okay? We're going to have to go at it with change in Y equals V initial t plus 1/2 a t squared. You know, this is 13.5 meters. Actually negative 13.5, excuse me, because it went downwards. Otherwise we're going to get a square root of a negative number. 0 times t plus 1/2 times negative 9.8 times t squared. Okay? With that, we end up getting negative 13.5 equals negative 4.9 t squared. And we then get that t equals, excuse me for a second, I gotta look it up, and I haven't solved it yet. We get 13.5 divided by 4.9, and we get the square root of that. We get t equals 1.66 seconds. Okay? We can then take that same time and put it in here. Now, what are we trying to find? We're trying to find change in x. So we know v initial, a, and t, and we're trying to find change in x. So again, we're going to have to use the same equation. We get change in x equals v initial t plus 1/2 at squared. Since our acceleration is 0, it just comes out to be 12 times 1.66. Which, if you do the math out, comes to be 19.9 meters. Now, what does that tell us about the yes or no question? What it tells us is that the pumpkin reaches this point. Okay? This point where it is 1.5 meters off the ground and 19.9 meters away from the school. Therefore, we can redraw the projectile motion as going to that point. And we know then that it clearly misses CA's car. So, to recap, zero launch problem, or really any two-dimensional kinematics problem, first thing we want to do is separate x and y. Then you're going to solve for t usually, and use t to cross over to one of the other ones.